Okay, here's lemma 2, and it states that for any homomorphism, the inverse image of a subspace of the range is a subspace of the domain. In particular, the inverse image of the trivial subspace of the range is a subspace of the domain. Okay, so now the proof is pretty straightforward. Again, we're going to use the fact that, in order to prove that something's a subspace, it has to be non-empty, and then we show that it's closed under linear combinations. Okay, so proof says let H be a map from V to W between these vector spaces and be a homomorphism, and let S be a subspace in the range space of H. Now we're going to consider if we consider the inverse image of S, it is non-empty, right? So that set is non-empty because it contains the 0 vector, since H of the 0 vector in V is equal to the 0 vector in W. So the trivial vector maps to the trivial vector, and the 0 vector in W is an element of S, as S is a subspace. Now, now that we know it's non-empty, to finish, we show that the inverse function of S is closed under linear combinations. Okay, so to show that, it's pretty straightforward. All we have to do is take two vectors in V, right, such that they map to S, right? So let V1 V2 be two elements in V, right? The elements in V such that H of V1 and H of V2 are in S. Okay, so we start with that. Then C1 V1 plus C2 V2 is in the inverse image of S, and why is that? Because what can we do with this linear combination, right? So what can we use to show this? Well, let's just take the mapping of it. Right? So use the fact that this is a homomorphism. So if we take H, so if we take H of C1 V1 plus C2 V2, that's going to equal C1 H of V1 plus C2, times H of V2. And what does that tell us? Well, this is a member of S. And we're done. Have a great day.